In section 6 of chapter 3, we're going to be going over another factoring technique. I will forewarn you, this is one of the easier factoring techniques, but it is one of the more complex and difficult ones to visualize and see. So I highly recommend you follow along with me and ask any clarifying questions as they pop into your head, because it's really important that you know how to recognize and visualize how to do these problems, because they will show up. All right. First, I want to kind of review and cover greatest common factor, because what this technique is, which is factoring by grouping, it stems from this technique. Now, if I gave you that problem, negative 7x times y plus 9 times y, I'd hope that you would look at that and recognize, like, oh, wait, they both have a y in common. Therefore, you could factor a y out and be left with y times the quantity of negative 7x plus 9. None of this should be surprising to you. That's how you do GCF. That's how you factor it. You'd be done. But remember, y is just some unknown quantity. It could be the number 5. I could replace it with negative 16. I could replace it with x. I could even replace it with an entire expression, x plus 1. And that last bit's going to be important. So just like how I could factor out that y, we're going to do the exact same thing with this problem. It is the same problem. I just replaced y with z minus 2. So just like how this problem, they both had a y in common in this binomial, this binomial, they both have a z minus 2 in common. Therefore, just like in the first problem, how I could factor out a y, you could factor out that monomial. For problem 2, even though the z minus 2 is a binomial, because both terms have it in common, you can factor out a binomial. So this would become z minus 2 times negative 7x plus 9. Again, all I did is I replaced this y with z minus 2. So in the same instance that we could do GCF with a y in this problem, we should still be able to do the exact same process with a binomial. This is factoring by grouping, or at least the foundation. We're going to expand on it because we technically didn't group anything here. But this is the foundation for factoring by grouping. It's doing GCF on things that are more than just monomials, doing it on binomials and trinomials and more and more and more. Here are my last two problems I'm going to work on. Technically, the first one's not factoring by grouping, but it does allow you to do one last thing. So my first problem, in green, I have 5a times the quantity of 2y minus 3 quantity, plus 2 times the quantity of 3 minus 2y quantity. Now this looks very similar to the problem I just got done doing, but there's a little hitch to it. This is a 2y minus 3. This is not a 2y minus 3. They're very similar, but they are in fact different. But let me rewrite it and maybe you'll see how we can get around this fact. If I rewrite the second portion as the following, negative 2y plus 3, maybe you'll recognize that the parts in the parentheses are in fact different, but they're only different in a minor way that we could actually adjust. This is a positive 2y and a negative 3. This is a negative 2y and a positive 3. I can turn this negative 2y plus 3 into a positive 2y plus 3 if I factor out a negative. So it would become 5a times 2y minus 3 minus 2 times positive 2y minus 3. So all it is, I factored out a negative. And now the two parts in the parentheses are exactly the same. And then according to factoring by grouping, as long as this binomial and this binomial are the same, I could factor it out And then I would be left with the 5a and the negative 2. 5a minus 2. And that's my answer. But realistically, the second problem, these are what factoring by grouping problems more often look like. Just like how difference of squares are really easy to recognize because there's only going to be 2 terms and we're subtracting them, so they're really easy to recognize, oh, I need to use difference of squares. This is the same thing. Factoring by grouping will largely only happen when there are 4 terms. We've been factoring a lot of problems with 3 terms, like x squared plus 5x plus 6. This is a problem we're going to be factoring with 4 terms. There's going to be 4 parts to it. Now the way we do factoring by grouping is kind of in the name. We are going to group parts of this problem. We're going to group the 2 highest powers of x and the 2 lowest powers of x. And what we're going to do is we're going to take the GCF, the greatest common factor, of each group. So the first group is a 15x cubed plus 5x. Well, 15 and 5 are both divisible by 5. And the first term has an x cubed. The second term has an x squared. Therefore, they both have an x squared in common. So if I factor out 5x squared out of the first 2 terms, I'll be left with a 3x plus 1. The second grouping, I have a negative 6x minus 2. They are both divisible by a negative 2. You factor out a negative 2, you'll be left with 3x plus 1. Now notice, the 2 sets of parentheses in our binomial are the same. It's exactly like this problem right here. The 2 sets in the parentheses are the same. That means we can factor it out. So I can factor out the 3x plus 1 because in this binomial, they both have that in common. And it'll become the quantity 3x plus 1 quantity times the quantity of 5x squared minus 2 quantity. Now, while we are in fact done with this problem, that is the answer, I do want to caution you because there is the possibility that you won't be done on the problems you have in front of you. This was a binomial where one of the terms was an x squared. There is the option that this could have done factoring by grouping and this could have been factored again. Like if this was just x squared minus 4, that's a difference of squares. Be aware of that. Factoring by grouping does not mean that you're done factoring once you do the grouping technique. You might have to factor again. Most of the time you won't, but occasionally that second little bubble might be something you could factor again. It will typically, almost exclusively, be difference of squares.